A local area network, or LAN, gives the nodes that are connected to it direct access to one another. A LAN usually has one or more Ethernet switches. But if you want computers on different LANs to talk to one another, you would need a layer 3 device, usually a router. So what is a VLAN? A virtual LAN, or VLAN, abstracts the idea of the LAN. A VLAN might have a subset of the ports on a single switch or subset of ports on multiple switches. By default, systems on one VLAN don't see the traffic associated with systems on another VLAN on the same network. But why do you need a VLAN? Well, VLANs allow network administrators to partition their networks to match the functional and security requirements of their systems. This way, they don't have to run new cables or make major changes in their current network infrastructure. So a VLAN is a group of end stations that are independent of their physical location. Basically, a VLAN has the same attributes of a physical LAN. Well, with an important exception. It actually lets you group end stations even when they are not physically located on the same LAN segment. In other words, it's a logical broadcast domain that can span multiple physical LAN segments. Now let's take a look at an example here. We have people from different departments in all 3 floors of a building. You can group stations that are segmented logically by functions, project teams, and applications. And it doesn't matter which floor they're on. You could partition people from different departments to a logical LAN or VLAN. In this example, all employees in the HR department will be in VLAN 3, and all employees in the sales department will be in VLAN 4. Ports in a VLAN share broadcasts, but ports in different VLANs do not. And what does this mean? Well, this means that if some workstation in VLAN 3 sends a broadcast, only the other devices in VLAN 3 will be able to see this broadcast packet. And this is a good thing. Containing broadcasts in a VLAN improves the overall performance of the network. You can have a VLAN on a single switch, or it can span multiple switches. VLANs can include stations in a single building or multiple building infrastructures. But it's not that simple. There are a few prerequisites for this to work properly. If you want to carry traffic for multiple VLANs across multiple switches, then you need a trunk to connect the 2 switches. Let's take this example. Here we will need to carry traffic for VLANs 2, 3, and 4 between the core switch and a switch on each floor. We've named them SW1, SW2, and SW3. So what you'll have to do is configure several trunk connections, and those are between the core switch and SW1, the core switch and SW2, and the core switch and SW3. VLAN trunks with IEEE 802.1q tagging facilitate inter-switch communication with multiple VLANs. If you have connectivity from one VLAN to another VLAN, that's called inter-VLAN routing. And you need to configure it on a layer 3 device. Remember, a layer 3 device can either be a layer 3 switch or a router. Then you'll have to configure, or we can say create, VLANs 2, 3, and 4. You will also have to place ports on each floor switches in individual VLANs. For example, you will need to place the port Fast Ethernet 0/2 on switch 1 to VLAN 2. So how do you create a VLAN? Well, to create a VLAN on a switch, enter the VLAN configuration mode and use the VLAN global configuration command. Let's take a look at how to add VLAN 2 to the VLAN database on SW1 and how to name it. We'll name it data. So to add an Ethernet VLAN, you will have to specify at least one VLAN number, or you can also define the name for the VLAN. But if you don't enter the name, the default is to append the VLAN number to the VLAN command. So here, if you don't specify a name for VLAN 2, VLAN 0002 would be its default name. Okay, now we've created the VLAN. That's done. The next thing you need to do is place the port Fast Ethernet 0/2 in access mode and put it in VLAN 2. When an end system is connected to a switch port, it should be associated with the VLAN in accordance with the network design. And how do you do this? Well, by assigning a single data VLAN to the switch port to which the device is connected. This port is called an access port. A port can only belong to one data VLAN at a time. When you assign a switch port to a VLAN using this method, it's known as a static access port. To set the interface to access mode, use this command, switchport mode access. On most Cisco Catalyst switches, you can configure the VLAN port assignment from the interface configuration mode. You would use the command switchport access VLAN. Now let's take this one step further. How about if you want to add some IP phones to the switch? How is this related to VLAN configuration on the switches? Cisco Catalyst switches have the answer. They offer a unique feature that's called the voice VLAN, which lets you overlay a voice topology onto a data network. You can segment phones into separate logical networks, even though the data and voice infrastructure are physically the same. You can see that if you have phones in their own VLANs, it's much easier to identify and troubleshoot network problems. The voice VLAN feature allows voice traffic from the attached IP phone and data traffic from an end station to be transmitted on different VLANs. Let's check this example. Here, the interface fast Ethernet 0/2 on the switch SW1 is attached to the IP phone, and then this IP phone is connected to the end station. When an IP phone is connected to a switch port, like we have here, the port should have a voice VLAN associated with it. So where's the process for creating a voice VLAN? You can create a voice VLAN the same way you create data VLANs. That means using the VLAN global configuration command. Let me give you an example. Here, we're adding VLAN 3 to the VLAN database, and we're assigning this VLAN as a voice VLAN to the interface fast Ethernet 0/2. Then you want to set the voice VLAN to an interface, and you do this with the command switchport voice VLAN VLAN ID. So here, we assigned voice VLAN 3 to the port fast Ethernet 2. Remember, you can configure data and voice VLAN on the same interface. That's what we did here. We assigned data VLAN 2 to the same port. So after you've configured the VLANs, you should validate the parameters for that VLAN. You'll find this command very useful, the show VLAN command. This will give you information on all configured VLANs. So what you'll see is the configured VLANs, their names, and the ports on the switch that are assigned to each VLAN. If you look at this example, the output has all the information about the voice and data. So here, data VLAN 2 and voice VLAN 3 were assigned to the interface fast Ethernet 0/2. All other interfaces are assigned to the default VLAN, which is VLAN 1.